Hi, hello everyone. Welcome to this video. So last time basically we left off basically we just set up our basic physics, and as you can see here it kind of works. So for this video what I want to do is just debug physics. And how can we do that? Well, we can draw the lines or something like that, and the bullet itself has a class which we can find useful. It does not have, however, it doesn't have any rendering. So we're going to do that. We're just going to render whatever data is provided to us by bullet physics engine. And why do we do that? Well, because it will become easy once you start doing terrain, because you might not actually know how the bullet represents our terrain, right? So we're going to do that. Before that, I just want to give shout out to one of you. I believe it's Danilo, because he found the bug. So I just have to fix that bug in our shader module util. And when here, I used byte pointer, I believe, or something like that. But anyway, whenever we have a pointer, right, we should probably release it. So I didn't do that. And there are probably a couple of more places where I didn't do that. So yeah, this code, right, it's not bulletproof. I just was coding something that can be used as a sample, right? So the practices are probably not the best, but let's just release it. So we need to release first of all this code, right? And then also I used label, so that should probably be released as well, as it's what's suggested here. So that should be fine, and maybe even message, right? Well, it throws exception and then the program is done, so let's ignore that one. Actually, it might not be a bad idea if someone wants to recover from this message exception, so that might not be a bad idea. And actually, this is pointer to string, so let's forget about this one. Anyway, this is it. So there might be some more places where we have pointers and which are not released. So I would advise to be mindful of that. But anyway, let's go further. So what we need to do is create our drawing class, basically. So what is it going to be composed of? Well, basically bullet provides us with data, right, where our points are, where the points are of its collider. For example, it will provide you with the data, right? Let's just try to run this again. It will provide you probably with the vertices, right? So maybe vertex here on a cube, here, right? And then we just need to render them somehow, and we're going to use lines because it's very simple to do. So let me just see my nodes, because I need to create the debug object, right? So let's start with that. Okay, so let's start just by creating new folder, and then we're going to call this one debug objects. I previously called it debug, and what happens is Git will actually check for debug folder. So I would advise, if you know git ignore, if you set it for Visual Studio, it will check actually for debug folder. So I don't recommend renaming your folder debug, it might cause issues. So I'll just use debug object, and I'm going to call this bullet debug drawable. And here what I want to do is, this will be easy. So the bullet has its own class, bullet not debug drawable. I think it's something like, let me check quickly because I don't know this by heart. It's actually called debug draw, and it's provided by bullet, right? So if we just implement our abstract class, we can see here we have debug. So first of all, we need to set the mode, and by default we're just going to set draw wireframe. So you can play with the other modes that you have. For myself, I'm just going to use wireframe because it will work good enough in our case. If you want to play with the others, you can. And then draw 3D text, we have to implement it, but we won't. Neither are we going to do this. We're just going to draw lines. right? And you can already see the data here that we get. We get from, right, to vector. So these are in world space. So we just need to have a view and perspective camera. So we don't even need to worry about transform camera. And then we have color as well. It's just color coding for different kind of meshes. And what we're basically going to do is just create a pipeline, right? That's going to render basically a wireframe. And that's how we going to approach this. So for start, I guess we can start with the pipeline. So I'm just going to call it, can be called wireframe pipeline because it's going to draw wireframes, I guess. And then as per usual, we're going to be very lazy, just copy stuff over, and then we can modify that stuff. So let's be lazy. And then we're also going to need shader. So actually, let's start with shader. That might be a better approach. So here we need new text file. I'm going to call it. It's not actually wireframe because we could draw anything with the shader, but I'm going to call it like that just for consistency. And then let's copy our unlit. Copy it here and then see what data we're going to need. So since we're doing wireframe, we probably don't need texture coordinates, so we can get rid of this, texture coordinates, position and color, right? We're going to use that. Why? Because it's actually provided by us by this object, right? From to, and then we're going to have color as well. So we need that. Transform, we're not going to need it because it's already in world space. So we need to change bind group here to 0. And then texture coordinates we don't care about here. Just get rid of transform, right? Multiplication. All of this can go out. And then the only thing that we need to return is this in color. And since it's actually, if you check the backdraw, its color is actually just vector 3. So we can change this as well. So we're going to do that. And then here it needs to be vector 4 type, right? Vector 4f. In color, and then we just use 1.0 before full opaqueness. Is it? That's how it's called. Anyway, yeah. So pretty much we're done with shader. We just need to remember to do here copy if newer, and then we're done with it. Okay, cool. So we can go to our wireframe pipeline. So let's first change the shader because I'm probably going to forget it later on. So whenever we see create shader, and I don't see it, so it means okay. Let's forget about it. I'm probably going to make this mistake, but let's see what do we need. So here, first of all, it needs to be unsafe, right? So that we can work with pointers. Vertex buffer, it's going to be passed in, right? So we're not going to need it. Right here, camera, that's fine. We do need that information. So do we do here, but we don't need anything related to texture. That's gone. All right, we need to change here wireframe pipeline, and anything related to texture we don't need. Label, we can leave that. So this is related to texture. Let's get rid of this. Vertex buffer as well. Geometry, we don't need it. We actually don't need this whole create resources method. So create bind group layouts. So we need to be a bit careful here. So we just really have one, right, in our wireframe, and that's for the perspective view. So we can keep this, all of this. Bind group layout, this is fine. Then this related to texture we can delete, so we don't need to worry about it. Then texture bind group, all gone. As you can see, it's very simple. We're just deleting stuff. So camera bind group entries, this is fine, right? We need projection view, but not skybox projection view buffer. So we need projection. We actually need buffer, right? If I remember correctly in our camera. So what did we use? We had specifically one for skybox, right? Where we, if I remember correctly, we got rid of translation exactly, and then the buffer is the one that we need. So probably not the most convenient way. It might be probably better projection view buffer, but all right for now. I'm going to leave it as is. We can get rid of this. Camera bind group layouts. We do have here are shaders. So this is called wireframe. Wireframe, and I'm just going to call this one wireframe. We can get rid of this. Be mindful here. So count this one as is here as well. Oh yeah, one exception to pointers, right? If you stack allocated, they're going to be stack deallocated as well. So you probably don't need to release, for example, this one, what I mentioned earlier today. Okay, further vertex attributes. We actually need two attributes, right? Because we have position and color. So let's create a color attribute. Color format, it's 3, that's fine, right? Why 3? Because we used 3 for color, if you remember. So we have to RGB, we don't have A, right? And then we have here XYZ for position. So here attribute count is now 2 and array stride is 6, right? Because we have 3 for position and then we have 3 for color as well. Offset here is fine, shader location is 1, that's fine. Okay, create resources we don't have. We're probably going to need to pass additional information to our pipeline, but we can do that a bit later. Okay, we don't have this bind group. Now buffers, we're actually going to pass vertex buffer. And we can pass event vertex count as well. Why? Because we might not want to draw the whole buffer, right? So how is it going to work? Maybe I should explain that. So let's just quickly discuss how this will work. So basically, if you imagine cube here, right? It will have vertices, right? So this is something that's drawn by bullet physics, right? It's not drawn actually, but it will provide us by these vertices of a cube, for example. And we're going to get that in this method that I mentioned, lines. And what we're going to do is we will get, for example, let's say this is vertex A. We're going to get A and B. We're going to get A, B, right, position. And so we're just going to have a large buffer, right? And we're going to write A position, then we're going to write color for A, then we're going to write B position, then we're going to write color, right? And then let's see, say here C, then we're going to say have C color, then let's say here D color, etc., right? So this will be our buffer. We're just going to fill in one big buffer, and then for the lines, we just need these two information, right? So we have here V0 and V1, right? And then we're going to have V2, for example, V3, etc. And then we're just going to use these pairs, right, to create lines. So this is roughly how this is going to work. It shouldn't be too hard, though. So let's go further. So now that I have explained that, so vertex buffer, we do not need to dispose here anything. We can get rid of this. We can get rid of this. Do we need to dispose anything else? I'm not sure. Maybe I would recommend for you to check it. But anyway, I think well, this is our pipeline pretty much done. Okay, so further, so let me think. In our bullet debug drawable, we're going to need that pipeline. Wireframe pipeline. Didn't I not call it like that? I did, and it cannot find it. Is it because it's not public? But it's still eternal, it should see it. Ah, here, found it. So we can just say pipeline, So what do we need to do? As usual, we're probably going to have initialize method, public void initialize, right? And we can say our pipeline is new wireframe pipeline. And we can see here we need some information. As usual, we're probably going to need our engine, and then we're probably going to need our camera. So we can just paste it in. Engine, oh come on, camera, and then the label. Serious, I cannot type today. The label can just be bullet. Debug, above. I don't care. And then we just need to initialize as usual. But we're also going to need vertex buffer. And we can create it here, but initialize it a bit later. So how this is going to work, we're just going to create one big buffer. And here we're just going to add some constants for that buffer, I guess. So we can say const integer vertex elements. So this is just going to be number of our elements in a single vertex. And we have x, y, and z for position, and then r, g, and b for color, right? So we're going to have position and then color. So it can be 6, and I'm just going to add here, so just so that you don't wonder, x, y, z plus RGB, and then not times 2 because this is a single vertex. And then vertices per line, that's actually 2, but let's say vertex elements per line better. So it's just vertex elements times 2, right? Because we have 2 vertices for one line. And then we can get our data, which is just going to be array. And we can say vertex elements per line, right? And then times the number of lines that we want to potentially draw, right? So you could essentially resize this array, and then you would have to resize the buffer, but I'm going to fix it. And I'm going to say we can draw like 100,000 lines. So we can just do that, 100, right? And then here. And in C#, this is quite handy. You can do this underscore just as kind of delimiter. This is still 100,000. It's same as saying this, but just for readability, you can do this. Okay. So further, we can initialize that vertex buffer, right? So initialize it with our data. And what's the second parameter? Vertex count. Do I need to pass it in? I don't remember my own code here. I guess no. No, this is just this information, but we're going to paste it in our pipeline. So we can do that actually. Here we're going to have new public void render, and this is going to be part when we actually render. So we can say here pipeline render, right? Vertex buffer, and then vertex count. So yeah, let's just create a new variable, private integer, and we're going to call this one count vertices. And I just wanna have one more, right? Because, right, we're counting vertices, and we're going to have 2 vertices per line, but this data index is just going to be our index for elements within a vertex, if you know what I mean. So maybe I can show it. Let's try it. So basically, right, this count of vertices, right, if you remember, now buffer, we can separate it like this: vertex 0, vertex 1, vertex 2, but I'm going to use data index to count the actual data. So the vertex 1 will be x, y, z, and then r, g, and b for color, right? This is this one. Then vertex 1 is vertex 2, or the ones that we indexed here, is this over. Then this one is once more x, y, z, r, g, b, etc. So yeah, and that's how this is going to work. And as soon as I actually start with this method, I think it's going to be clear. So if our count of vertices is greater or equal to 1000, we return, right? We're just not going to draw on the whole thing. So there are a couple of options here. You can either assign a greater vertex buffer, right, with more elements, or you could resize it whenever you need it. If you see that you need resizing, you can actually do that. I'm going to leave it to you. For me, I just want to do nothing, right? I'm just going to skip it because we're probably not going to have that many elements. Probably not going to be necessary. It might. We're going to see. But count of vertices is 2. Why? Because we have 2 per line, right? Okay, and then we actually need to fill in our data, and here is where the data index comes in, right? So x, y, z. So I can just say here vertex 0 for the first vertex, and then we fill in the color, and then we have second vertex, and I should probably make this bigger. Okay, 2, 2, and this is fine, right? Once again, we're writing color. And you could actually even save on some data and get rid of the color and just have single color as a uniform or a global. But yeah, it's not necessary here. Yeah, this is fine. This is fine. Okay, and then so now we need to pass in count of vertices, and whenever we draw, right, I just want to restart everything from the beginning. So I'm just going to say data index is 0 as well, and here this is integer, but we used uint here, so I'm just going to cast it in theory. You could also just make this as a uint by default, and then finally, right, because we're drawing to we're filling our data, but we're actually never updating our vertex buffer with that data, and I don't have update method on our vertex buffer, so we can create that. That's going to be very simple. Update, and then we can just paste our data in. But let me see, how did I imagine this to work? And we can paste our data in, so I'm just going to use it like this, right? So what I need is real length, so I'm using -1 here. If it's -1, we're just going to fill in the whole array, right? So let me write it, and it's going to be very easy. Okay, here it's already suggested. So if it's -1, right, it's just going to use data length. If not, then it uses this length. And I usually don't do comments in this video, but here I'm going to do it because it might be confusing. So here I can just say the data, that's not relevant, but this one is confusing probably. The length in bytes, right? If -1, the length of array is used instead. Okay, and then we could actually do it here. We just need fix, right? Float data pointer to a data, and here this is exception. We don't need to release it, right? Because it's just fixed here. And then we can use our engine WebGPU write buffer. So here, let me just see parameters. We don't have any offsets. So our data and then the size. So this is the wrong suggestion because it's reversed. So here it's data pointer, and then we have real length here. Okay, I think we're good. We can just say here, hey, let's update, and then we need to pass the data in, which is going to be count of, data index times size of float, I believe it should be. Okay, here it's data index. I think this should be fine. If I got that right. I think yes, because we have data index is going to be count of elements, right? And then each element is a float type, so it's size of float. Yeah, that's correct. Okay, so we're almost there. I think this debug drawable is pretty much fine and done. So when we created a scene, where did we create a scene? In our terrain scene. So we just need to set up basically the bullet to actually use that class. And for that, let me just see my notes once again. Okay, we're probably going to need that object, and what did I call it? Okay. So we're just going to create bullet debug drawable. We probably need to resolve it. So control dot is kind of shorthand. Here, then we can probably create it somewhere over here. That's not super relevant where exactly. So we need our bullet debug drawable, new, engineer camera. Then we need to initialize it, right? So this will create our vertex buffer and our pipeline. And then, so here is the important part, right? The world that we previously passed in has the bug drawer, right? And this is where this interface comes in, right? So if we navigate here, you can see it has the bug drawer. If you remember, right? If you remember, we actually inherit from it. So this is how it's done. Okay, and then we need a couple of more things for sure. So I'm just going to say here const bool debug. I'm going to set it to true. So we can say here if debug world, and then we just need to call debug draw world. And we finally need to render that pipeline that we created. Sorry, not the pipeline, the object, right? Bullet debug drawable had the render function, right? So if debug, we can say render, right? So what did we do here, right? We just updated our vertex buffer and then rendered the contents of our data. All right, moment of truth. Probably it's not going to be perfect because we still need a couple of more things. So it might work sort of, not really, right? All right, what's happening, right? If you remember, I mentioned that we need to draw lines here, but we're drawing triangles, so we need to set up our pipeline actually to draw lines instead of triangles. So that's our next step, and then we're almost done. So going back to our wireframe pipeline, so we're going to need that information. So here in create, right, we have all of this information, but we hard-coded here topology, right? So it cannot be, so if I were just to say here, I think it's line strip, or lines. Let me just see the result. Okay, you can see something, it's probably not line strips, my bad, but line list it should be. So right here you can already see these kind of lines. I mean everything is messed up because we're missing our skybox, but you can already see lines. So we're almost there. So it's just that this data, right, we now have to pass in, and we can do it sort of like this. Create a topology, and by default we can just say triangle list, and then here we're going to say primitive topology, and then in our wireframe, right here we can just say our primitive topology is going to be line list. And if we try it now, as you can see, right, our objects have lines, which is very good. So basically we're sort of done. So you can just check the results now. So if, for example, if we were not to draw this either crates or terrain, and if we try it, it should still work. Right over here, as you can see, it still works. It's just that now we have lines and wireframe. And the whole reason why we did this is basically just so that once we start working on terrain, right? Because we're going to use height map, and then the actual terrain might looks like something you create in Unity, right? So it really helps there. So I just didn't want us to like try and match terrain and then don't know what's going on. With this, we can always be sure that we know what's going on. And just one more thing that I wanted to do is I'm a bit annoyed by number of cubes here. So yeah, I'm going to create this. Okay, it's a bit easier to see what's going on. All right, and that's it for this video. So these colors, it's probably just like color of objects that are in motion or that are stopped. Like if it's stopped, you can see it's a green color. If it's in motion, it's going to use other color. To be honest, I'm not 100% sure how they did it, because the bullet documentation, it's a bit hard to find, right? But anyway, so that's it. Just a quick recap, because we covered not too lot, but just enough. So basically the whole idea was just to use this debug draw, right? And implement it. So we just implemented one of the possible methods. And here what we did is just fill in our data. And then when we call render, we updated the buffer, and then we drew that buffer in. So we were just drawing basically lines made of two vertices, right? So we write vertex 0, vertex 1, and then on the next line we would get another set of vertices, right? So we would write it again. And yeah, in our terrain, we just set our class, right, that we created, bullet debug drawable to the bullet. We needed to call debug draw world, right, from bullet, and then we finally need to render that. And yeah, that's pretty much it. Wireframe shader, it's very simple, right? We were just using position and color, and then the whole setup was very simple as well, right? There wasn't too much new here. With that said, that's basically it. So for the next time, I would probably, we're going to start with terrain. I'm not sure which part yet, so we're going to leave that for the next time. But I guess we should start setting up our vertices of our terrain, length and width. But then in the later videos, we're actually going to do height map and the texture mapping as well. So for the next time, we're just going to probably set some floor, which is similar to this one, but it's going to be a plane basically. And then later on, we're going to play with height maps based on that. Okay, that's it for this video. If you enjoyed it, maybe like, subscribe, leave a comment, and until next time.